Welcome on. Welcome to the fourth session of highway engineering. So last session we were discussing about super elevation and its various aspects. So we ended up the session saying like we will extend those concept by applying to numerical. So today's session is going to discuss about couple of numericals related to superelevation. So all these questions, what are the numericals we are taking, it has been taken from the textbook, highway engineering textbook authored by Khanna, Justo and Virragwan. So you can use that as your reference material. So this is the structure, like I will write the problem, then we will have an understanding about what is the problem, then we will quickly solve the problem. So the first question, the radius of a horizontal curve is 100 meter. The design speed is 50 kilometer and the design speed is 0.15. If these are the condition, calculate super elevation required if full lateral friction is assumed to develop. Second part is calculate coefficient of friction needed if no super elevation is provided. I hope the question is clear. Let's now understand it. So what is given data? Radius is given. How much it is? R is given as 100 meter. The design speed, that is nothing but V. The unit is in kilometer per hour. So 50 kilometer per hour. And coefficient of friction F is given as 0.15. Three data is given to you. First part is calculate super elevation. E has to be calculated if full lateral friction is assumed to develop. What is the design value? 0.15. Assuming full value of friction is going to develop, then calculate the super elevation required for a radius of R and having a design speed of V. So what is the equation we have? The equation is E plus F is equal to V square by GR. Since it is given in kilometer per hour, I am going to write V square divided by 127 R. Now, what are the values I have? It's pretty simple because I have the design speed value V. I have R data as given. And we are going to say like full friction, that is 0.15. So, substitute all the values and see how much is the E value you are getting. So, which is typically, let me substitute. Therefore, E is equal to V square divided by 127 R minus F. Okay, I'm just taking the F to the other side. How much is V? 50 kilometer. So 50 square divided by 127 into radius is 100 meter. No need to change the unit. Minus coefficient of friction is 0.15. If you are doing so, you will get an answer 0.047. Super elevation 0.047. Now, whoever wishes to tell in terms of one vertical to 1 in n, one vertical to horizontal ratio, you can write this as 1 in 21.2. This is how the super elevation. So you need a super elevation value of 0.047. Just recall, we said maximal limiting value is 7%, which is compared to that it is less, 4% it is coming to. So that is the first part. The second part of the question is calculate F needed if no super elevation is provided. So assume a scenario in which you don't have to provide a super elevation, but just see how much is the friction which it is required. So I am going to use the same equation E plus F is equal to V square by 127 R, in which E I need to calculate, F I need to E I need to assume it as 0 because no super elevation, sorry for the mistake, and F I am going to calculate here. So F is equal to V square, which is the same as 50 square divided by 127 into R is 100 meter. It is given 50 square divided by 127 into 100. If you are doing so, you will get an answer of 0.19. So, if you have understood this question by looking into the answers, one point is clear. If there is no super elevation, the friction, coefficient of friction or the lateral friction required is 0.19. This value can be limited to 0.15 if I am providing a super elevation value of 4%. So you can see that how the super elevation is helping it. So this is for the first problem. So we will take another example which typically will work on how much is this outer edge rise, vertical edge rise have to be calculated. So the question is as follows. A two-lane road with a design speed 80 km per hour has horizontal curve of radius r equal to 480 meter. Design super elevation for mixed traffic condition. If width of the pavement at a horizontal curve is 7.5 meter, how much should the outer edge of pavement be raised? This is the question. So let's understand the question. So there is a two-lane road. The two-lane road has a design speed V is given as 80 km per hour, and at the horizontal curve, the radius of horizontal curve is given as r is given as 480 meter. Now, what is that you are going to calculate? You have to calculate how much is the super elevation required for mixed traffic condition. Very important factor. Mixed traffic. This is the keyword here. Now, if the width of the pavement at the horizontal curve, the width is 7.5 meter. How much should be the outer edge of the pavement be raised? So what is that question asked? We please recall when we did the super elevation concept, we said super elevation or the rate of super elevation equal to tan theta is equal to height of outer edge. This is what we considered E divided by width of the pavement at the horizontal curve, which is nothing but B is something we wrote the equation as. So they are going to ask you, they are asking how much is this E. So E is equal to B into super elevation. So this is the equation I need to apply. So do I have the data of B? Yes, I have, because they have given width of the super elevation. So I am going to mark this as P. Do I have E? No. You need to design your super elevation first. So first step is calculate your super elevation, but for a mixed traffic condition. So what is this mixed traffic condition? Please recall when we spoke about design of super elevation, we said catering to the design speed, catering to the mixed traffic condition, you should be taking 75% of design speed, neglecting friction. These two criteria. That's the most important point you need to remember. So we wrote our equation as E plus F is equal to V square by GR. Right. So here this F is assuming it as 0, and this V we were considering it as 0.75%, 0.75 V square. Now if you want to write the final equation, I am going to write in terms of kilometer per hour. So it will be 127 R. So we got it as V square divided by 225 R. This was the equation. I hope you remember this equation. So here V is in kilometer per hour, R is in radius meter. Those two values we have. So directly substitute it. 80 square divided by 225 into R is equal to 480 meter. The answer you should get as 0.059. 0.059. This is the super elevation value. Now, just straight away don't use it. Please use the, please recollect that super elevation has a limiting value. The maximum limiting value is 7%. So you need to always cross check what is the design super elevation you got. If it is less than 7%, adopt that value. Otherwise, limit it to 7%. In this case, I got a value which is less than 7%. So I can straight away consider, I can take this design value. So substitute the E value here, substitute B, calculate the outer edge. So E is equal to, B is 7.5 into super elevation, I am taking it as 0.059, which is calculated as 0.44. The unit is in meter. So this is how the outer edge you need to calculate. Let's look into another example. So the question is as follows. Design the rate of super elevation for a horizontal highway curve having radius of curvature 500 meter and speed of 100 kilometer per hour. So what is the question given? You need to calculate how much is the superelevation required for a R radius 500 meter curve radius, a design speed of 100 kilometer per hour. What is the superelevation? It's a simple question. Calculate the superelevation for a highway curve. So highway curve means generally a mixed traffic operation. It doesn't have to be explicitly say like it's a mixed traffic condition. So for mixed traffic condition, if I am designing the superelevation, I have the equation E plus F is equal to V square by GR or V square by 127R. So mixed traffic condition means design speed. I'm not taking the full design speed. I'm taking 75% of it. So it will be like 0.75 V square 127 by R. I am neglecting friction. So F is equal to 0. And this value is V square divided by 225 R. Right. This is the equation we have. So you can use it. I'm just explaining how we got the equation. So if I am substituting 800 kilometer per hour divided by 225 into radius is how much? 500 meter. Okay. So the E value you are going to get is 0.089. This is the superelevation required or required for considering your mixed traffic condition. Now, do we have any problem? Yes, we do have problem because the E value we got is 0.089, which is greater than the E max value of 7% or 0.07. That means I cannot consider this as my design superelevation. I need to limit the superelevation to the maximum available value 0.07. Now, if I am limiting, so you need to write that you need to limit superelevation to E max, that is 0.07. So you are saying you are considering design superelevation as 0.07. But in that case, what is the next thing you need to check? You need to check how much is the friction, coefficient of friction developing, assuming the full speed. So assuming full speed means 100 km per hour. So the equation is the very old equation E plus F is equal to V square divided by 127R. I am writing in terms of V applying in kilometer per hour. So here what is that you are going to calculate? F. So we can write F is equal to V square by 127R minus E. Now directly substitute. V square is 100 square divided by 127 into R is 500 meter minus friction value 0.07. Please understand, not the calculated, we limited into the maximum value. So I need to consider 0.07. If you solve this, you will get a value of 0.087. Friction is 0.087. So what is it talking about? Maximum value of design value of coefficient of friction, how much it is? Your limiting value 0.15. And what is the value you are getting? You are getting 0.8. That means it is less than 0.15. It's a safe case, right? If I adopt a value of 7%, if I limit my superelevation to 7%, with the full design speed, I have the frictional coefficient or the coefficient of lateral friction is coming around 0.08, which is considerably less than the design friction. So that's a safe criteria to adopt the superelevation to 7%. This is how you need to do the problem. Let's take another problem. So the design speed of a highway is given as V equal to 80 km per hour, and the horizontal curve at certain locality is having a radius of 200 meter. The design of coefficient of friction is given as 0.15. I have just wrote down the data. So calculate the superelevation required to maintain the design speed. Second part of the question is, if the superelevation is not exceeding 0.7, calculate the allowable speed VA as it is not possible to increase the radius. So they are giving you a hint like it is not able to increase the radius, so calculate the VA. So this is the question. So let's analyze the question little more detail. So first part of the question is calculate the superelevation for the given data. Now what is the allowable speed if there is no possibility to increase the radius? So that means it typically asking for you to check what is the designs of superelevation, the 4 steps we need to typically follow it. So first calculate the first step, superelevation required. So E is equal to, always remember equation I am going to write V square divided by 225R. This superelevation we are going to consider for assuming 75% of design speed, neglecting the friction. That's why F is not coming into picture. So substitute the values. V is given as 80 km per square, 80 km per hour. So 80 square divided by 225 into R in meters is 200 meter. So if you are doing so, your answer is 0.142. Okay, E value is 0.142. What is the meaning of this? Superelevation 0.14. Is that possible? No, because so write as allowable maximum value of superelevation is 0.07. Not the one we calculated 0.142. You need to limit it as 0.07. Now if you are limiting it, what is the next step immediately? Calculate the friction for a full, assuming the full design speed, not for the 75%, full design speed. Now I am going to write only the equation. I am not deriving the equation again. So the equation is E plus F, right? So here F is equal to V square divided by 127R minus E. Minus E, right? But this minus E is the value. Okay, let me write minus E itself. Minus E. So how much is V square? Let's substitute. V is 80 square divided by 127 into R is 200 minus 0.07. Please don't substitute 0.14 because we limited. There is no significance of this value now. This is limited to 0.07. So minus 0.7. This will give you an answer 0.18. 0.18. So what is the meaning? You got the friction for the full design speed 0.18, but the design speed of lateral coefficient of friction is 0.15. That means it's greater than 0.15. This is not a safe condition. So only two possibilities here. Either increase your radius of curvature or have a restriction in speed. That's something called as calculating your allowable speed. And they said very clearly it is not possible to increase the radius. So one option is ruled out. Then other one is like calculating your allowable speed. So let's calculate the allowable speed. So here write it as the friction you have to again limit into 0.15. You cannot consider this friction value. So write it as the allowable maximum coefficient of friction, lateral friction is 0.15. Now calculate the allowable speed. Do you remember the equation? So the equation is something we have written as allowable speed, because let me write that E plus F is equal to VA square divided by GR. This E and F we said maximum values, that is E is equal to 0.07, F is equal to 0.15. So if you add both 0.7 plus 0.15, 0.22 you will get. So VA is equal to GR into 0.22. That's how we have written the equation. So 0.22 into G into R. This 0.22 into G, again we wrote the equation and we said if it is in 127 like kilometer per hour, how it is. So the final equation we got it as 27.94 R if it is in kilometer per hour. So substitute R, that is root of 27.94 into how much is R? 200. Okay, and the answer you are going to get is 74.5 kilometer per hour. I'm sorry, it's coming to the end point. 74.5 kilometer per hour. So what is the meaning? Though the design speed is mentioned as 80 kilometer per hour, since you have a certain restriction in your increasing the radius, you are not in a position to provide the designed super elevation of this value. And if you are looking at the friction, again friction is also not at safe position. So there is only one option for me to restrict the speed. How much is the speed you have to restrict? You have to restrict from 80 km per hour to 74 to 70, approximating it as to 75 km per hour. This is what the practical meaning of it. And please also mention that apart from this, the warning messages, the signboards have to be given. Okay, I hope that is clear. Let's look into another example. So the problem is like this. A major district road with thin bituminous pavement surface in low rainfall area has a horizontal curve of radius 1400 meter. If the design speed is 65 km per hour, what should be the super elevation discussed? So let's look a little close to the problem. Thin bituminous pavement surface, a major district road, low rainfall area. This is what the site condition has been given. And what is the data given? You have a radius of curve 1400 meter. Design speed is 65 km per hour. You need to calculate E and discuss about the E value. What is the E value you are adopting for the design? So how do you calculate? You will first start with calculating what is the design of your super elevation. So E is equal to V square divided by 225 R. We are taking the same equation considering negligible, that is neglecting the coefficient of friction and assuming 75% of the design speed. So this will give me an answer 65 square divided by 225 into radius is 1400. So the answer is 0.0134. This is the super elevation value you are getting. Now, please pay a little more attention when we discuss about the limitations, limitations in value of super elevation. So we discussed maximum value and what is the minimum value of super elevation. So the minimum value, we are going to talk about the minimum value here because we got a super elevation which is quite low, 0.01. That is hardly you are going to talk about 1%. 1% is the super elevation you got. That is what we are going to discuss about, or going to recollect what we discussed in minimum value of the super elevation. So when we discuss minimum value of super elevation, there are two things we specified. The first thing was if check for your super elevation value. If the super elevation value is lesser than or equal to the cross slope or the camber, then you can limit your super elevation as the value of the cross slope itself. If it is turned to be lesser than the cross slope, so cross slope is nothing but to drain off the surface run water, you will be raising the center, right? This is the crown. So this is what it is. So here, and this value, this cross slope value, whatever you are getting, if it is higher than the super elevation or super elevation is closer or less than the cross slope, then you can limit the super elevation value as the cross slope itself. But in that case, how you will do it? You will be considering, because you need to eliminate your crown and you need to provide as the super elevation, because you are going to adopt this cross slope value and providing it as the super elevation itself. So only raising the outer edge, so eliminate the crown, and whatever the cross slope from outer edge, provide uniformly the cross slope from outer edge to inner edge. So this is what we discussed. Second case we discussed, if you have a flat curve in which your radius is significantly high, the large turning radius, a flat curve in which a large turning radius is available, then what happens to the centrifugal force developed there? Centrifugal force is P is equal to W V square by GR. As the R value increases, your P value, centrifugal force developed, will be small. So the assumption is that since the centrifugal force developed is small, there is no need to provide the super elevation. So I can consider E is 0. You are not providing your super elevation. In fact, you can retain the camber or the cross slope throughout the horizontal curve. This is what another option. But when you are doing so, there is one point you need to check, because when I talk about the camber, what is that I am doing here? Raising the center portion. But in super elevation, it's the outer edge. So here specifically on the horizontal curve, outer edge of the lane, this is negative super elevation is developing here. Negative E I am marking. So make sure that the centrifugal force develop is less than the coefficient of friction, or in other words, the coefficient of friction, the frictional force is able to counteract the centrifugal force. If that is the case, one can go with the large turning radius with a normal camber. You don't have to worry about the super elevation. And we have even discussed and I remember showing a tabular column in which the IRC guidelines, the values for different sets of design speed, in which different values of camber we have considered, and we have seen like radii beyond which there is no need to provide super elevation. So we are getting into those concepts here. So I need to make sure here whatever the frictional force. So I have what is the opposing force for your centrifugal force? Super elevation and friction. Though you are not providing super elevation, there is a negative super elevation is creating in this case. So this negative E plus F, I need to look at, compare with my centrifugal ratio and see whether this is negligibly small or this is greater. If you are able to get into this criteria, then you can say that there is no need of providing super elevation. So this problem is particularly related to this concept. So what is the first thing you are going to check here? We are going to look at the value of super elevation, which we already calculated, and we got a value 0.01, 1%, which I know that less than the E max. Right, because E max is 7%. So I am assuming that I can go with a super elevation of 1%. Now I am going to check with, in such a case, what about the camber existing? So the cross slope or the camber. Now please recall when we discussed about camber cross slope, we said IRC has specified values for different type of road under defined rain condition, whether it is a low rainfall area or a heavy rainfall area. So for the given condition, thin bituminous pavement surface, low rainfall area, the value recommended is 2%. That is, camber value is 0.02. Now compare E and camber, which is higher. Your E is less than the cross slope. Right? This is 0.01. So what is my E value? I have to limit my E value to 0.02 camber value. Clear? That was the first step we discussed. Now, is that really need to provide this super elevation of 0.2, or should I retain to the camber? This is the next choice we need to discuss. Check for safety. So let's write check for safety against centrifugal force. Okay, because we need to make sure that if I am saying there is no super elevation required for the radius of curvature we have, but in that case the friction force or the whatever is in the lateral direction, skid resistance, is able to counteract the centrifugal force. So check for safety against centrifugal force, especially at the outer edge, considering the negative friction, negative super elevation and coefficient of friction. So first case we will consider what is the skid resistance. So the skid resistance, lateral skid resistance, that is minus E plus F. I hope that is clear. Why minus E? Outer edge, it is from the crown you are getting this way. So this is the middle. So this is the inner edge is having the raise. It's the ulta. So that's why negative super elevation. E value of 0.02, because we calculated 0.01, realizing that it is lesser than the cross slope, we limited it as to the cross slope itself, that is 0.02, plus design value of coefficient of friction is 0.15, which will give you an answer of 0.13. This negative sign is very important. Okay, negative E So 0.15 minus 0.02, 0.13. So this is what the skid resistance is acting laterally. Now calculate the centrifugal force. So the centrifugal ratio P by W is equal to V square by GR. The same equation you are using. So P by W is equal to V square by, let's apply it in the kilometer per hour. So the equation can be written as V square divided by 127 R. V is nothing but the design speed. So we are looking at whether it is safe to travel with the design speed. So 65 square divided by 127 into radius is given as 1400. If you solve this, you may get a value of 0.024. Now let's look into both the value, compare it. What is that you got it? You understood that centrifugal force develops is 0.024, which is quite less than the skid resistance 0.13. That means friction is in a position, frictional force is able to control the situation. It is safe to travel at the design speed of 65 km having a turning radius of 1400 meter. So the conclusion should be, in this case there is no need to provide the super elevation having a large turning radius of 1400 meter. The normal camber of 2% can be retained at the horizontal curve. This is the conclusion of it. See, there are more numericals I would like to solve it through these sessions. But due to the time constraints and other things, we are limiting to those problems which are like covering each of the various aspects or the design aspect in the super elevation. I would be happy if you have any queries or numerical problems. If you can type it and send it in the posted, so I'll be happy to reply for it. And as I already said, these problems have been taken from the textbook Highway Engineering, authored by Khanna Jastu and Veeraraghavan. There are more problems, even it has been listed for practice. You can work out, and if you have any queries, please let me know. Thank you.